In this lesson, we're going to start taking a look at using our idea of compound probability where you have two different events happening, and we're going to multiply those probabilities together to get your final probability of everything. But taking it one step further and saying, wait, do these two events impact one another? Or are they two separate events? So we're going to look at this idea of dependent and independent. Independent is what we've been working with so far. Two events independent events are two events that have no impact on each other. For example, does what you eat at lunch have any impact on what the weather is outside? The answer is no. It's not going to snow if you eat pizza at lunch. Those two events are independent. Excuse me. The reverse then is dependent. These are two events There are two events that do influence each other. So let's try this. Same thing. You eat pizza at lunch. Does that impact how you feel later? Those two events are dependent. All right. One helps determine what the other is. Let me show you some examples. So I have some items here on the desk. Here's a two-sided coin, yellow, red. If I flip this, excuse me, if I flip this and then roll a die, does this impact or have any influence on what this is? So if I flip this and it's red, does that mean that this is going to be an even number? No, it has no bearing on it. So if I roll this, oh, it's a 1. It has no bearing on it. These two events are independent. What if I do this? What if I flip this coin and then pick a color tile out of this bin? Does one impact the other? The answer is no. These are independent events. What about this? What if I move this other stuff out of the way? What if I flip this coin and it's yellow? I'm going to flip it again. Does that mean it's going to be red? Not really. I mean, if things are going to be 1/2 and 1/2, it should be red, but it doesn't mean it's going to be red. So flipping a coin twice, or flipping two coins, is also independent. Yellow. So if I flip it again, it should be red. Red. If I flip it again, it should be yellow. Yellow. If I flip it again, it should be red. Red. Yellow. No. So they are independent. I want to show you an example of something that is dependent. I'm going to pick a card. What's the chance that I pick a 4? Right now, it's 1, 2, 3, 4, 5. It's 1 out of 5 cards. Let's say I do pick a card and I don't put it back. And I want to pick a second card. Are my chances still 1 out of 5? I hope that you see it's not. This second pick is now dependent on my first pick. Because I did not put the card back in, I now have a new probability. So now I want to pick a 3. What's the chance of picking a 3? It's no longer out of 5. So what changes is going to be my denominator, the total number of choices I have. What's the chance of a 3? 1 out of 1, 2, 3, 4. That would be dependent. Let me show you one more. Whatever amount of tiles are in here, they're in here. What's the chance of picking a blue? 1 or however many blue out of however many I have. Okay? If I take a tile and don't put it back in, notice what has changed. To start with, the number of tiles I have changed. So when I start taking two probabilities and multiplying together, these two things are dependent. The second pick depends on what I picked first. All right, let's do the math for it. So let's take a look at the math. Let's first look at an independent event. I'm going to flip a coin and roll a die. I know those two are independent because one does not influence the other. So we're going to use the same math logic thought that we use for compound probability. Find the probability of each event, multiply them together, reduce, and that's my probability of the whole events put together. Probability of a head, 1/2. Probability of an even number. On a die 6-sided, 3 of them are even, 1/2. Multiply together. 1/2 times 1/2 is 1/4. So if I flip a coin, roll a die, if I do that game 4 times, one of them should give me a winner. One should give me a head and an even. So that is independent events. Take the probability of one event, take the probability of the second event, multiply them together. So again, what's different with dependent? Well, what's different with dependent, and again, I'm going to use my cards I did. I have 5 cards. What's the probability of picking an even and then an odd? Now, what's different is there'll be a note. I am not going to replace the first card I pick. So I have the numbers 2, 3, 4, 5, and 6. What's the chance? I'm going to do the same thing. Take my first probability, multiply by my second. What's the chance of my first probability? I have 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. What's the chance of an even? 2 is even, 4 is even, 6 is even. That's 3 out of 1, 2, 3, 4, 5. 5. So that's the chance of picking an even on the first card. So I'm going to take a card, that was my first pick, and I'm not going to put it back in the deck. So now take a look at what we have. What's the chance of an odd? Okay, now this is where it gets just a little tricky, you got to think about. Because you may be thinking, okay, I'm going to take away one of these cards. Which one am I taking away? Honestly, we don't know which one you picked first unless you actually go to pick it. So, the top number, how many we have, is still going to be based on the full list. Odd. How many odds do I have? Let's see, I have a 3 and a 5. Again, why? Because I don't know what I picked the first. I could have picked an odd, and it would take it out, and then I'm short one. But I don't know which one I picked. So my odd is 2. But you took a card away. Again, we don't know which one, but you took one away. So this number on the bottom no longer is 5. How many cards do you now have left to pick from? You now have 4. So the biggest change, or the biggest difference with dependent, is your denominator is going to be 1 less. Okay? Because you have to take into account you did the first event, which means you're going to be either a card short, or a marble short, or a tile short, whatever. So top numbers will calculate the same. We'll think about it in the same terms, but it's that bottom number that's going to reduce 1. So now I multiply, I get I can reduce this as 2 out of 4. I can change that to 1/2 now. So I get 3 out of 10. Becomes my final probability. So this is the math behind the difference of independent and dependent. Biggest difference is with dependent, in the denominator, in your total amount of outcomes, you have to deduct 1 because you took something from the first event that you did. Good luck. I want to show you one more extension to this, so to speak, or one more type of problem where it's a little different with dependent. Here's one for my Excel. You pick a card at random without putting it back, so it's going to be dependent. The second pick is going to be different because you have 1 less card. You pick a second card at random. Here's what's different. It's when the option you're looking for, they're both the same. So let's go through this, our thought process. So I have two events. One, pick an orange. Two, pick another orange. Let's do the first one. The first one, how many orange do I have? 1, 2, 3, 4, 5. I have 5. Out of how many? 1, 2, 3, 4, 5, 6, 7. 7. I have 5 out of 7. That's my first event. I'm going to multiply that by my second event. First of all, I've picked a card and it's now one less. So how many cards do I now have to choose from? I have 6. Here's where it's a little different. If it's the same event that you're trying to do, we're going to have to imagine that when you picked your first card, you actually picked an orange. So not only does it change the bottom number, 7 becomes a 6, it now is going to change the top number. And again, why is this different? It's because both events are looking for the same outcome. So if it's orange, orange, or yellow, yellow, or blue, blue, whatever it is, when they're the same, we're going to take a look and say, the first event, I'm going to pretend, yeah, it was orange. So that means this card no longer exists in my pile. So how many cards do I now have? How many orange? 1, 2, 3, 4. I have 4. How many total? 1, 2, 3, 4, 5, 6. So now I have 4 out of 6. So let's go ahead and multiply this. 5/7 times 4/6. And I get 10 over 21. Alright, now this is just my scratch pad here, so let's go back to the IXL. Let's type in 10 over 21. And it worked. Okay? So just one more extension I wanted to cover with dependent when it's asking for the same event happening in both.